looks like we're live. So let's get started. All right, so that's what we're going to be making today is these gears. And the interesting thing about them is that, okay, so we're going to be going into kind of more of the mechanical side of stuff, where you can see these are, whoops, get out of this view. They have all of the correct dimensions and beveling and whatnot, as well as topology. We're going for a more cleaner model this time, whereas normally I would just be, tossing planes and stuff and different pieces just randomly using a lot of photo scanned assets. But I wanted to go into gears and gear reductions as sort of a technical practice. So let's go ahead and get started. So just make sure everything is set up correct. Appears that it is. We're going to be using a website to calculate the mathematical functions for the gears called Advinta, which if I go ahead and disable this, ooh, that's my stream. You guys should be able to see this now. And that's what we're going to be using to calculate all of the different gears. So first we'll start off with just a simple 12-tooth gear. And we're going to do that over here. Just set the M to 1, and then number of teeth we want to set to 12. Oop. And you'll see as soon as we hit calculate, it's going to give us a bunch of mathematical functions down here, as well as some other numbers that we'll be using later, as well as tooth thickness, tooth diameter, base radius, base diameter, and pretty much all of the all the different measurements for our gear. So the first step is, once you're in Blender, I'm going to go ahead and hide all of this. We can go ahead and just disable this for right now. You're going to want to make sure that you have the extra add-ons enabled. In Preferences, go to Add-ons, and just make sure you have the extra objects enabled. And I forgot to turn on screencast keys. I should probably enable that. Where is it? I don't know where it is. I have not used screencast keys in forever. But we'll just leave them off right now. If we go to Add, Mesh, Math Function, and we go in XYZ Math Surface, you'll see we immediately get this cool looking like snail shell kind of pattern, and it auto fills in some mathematical functions for us, which is nice, but that's not the shape that we're making today. So where it says X equation, you want to go back to Advinta and just copy the X equation from the top box. Paste it into Blender, and you'll see immediately this skews horribly. If we do the same with the Y equation, copy and paste, hit enter, you'll see we start to get something that looks like the Fibonacci sequence, a little bit of the golden spiral. Set the Z equation to 0, because we're not doing anything with height. And check our, you want to go, okay, so U min, U max, and U step are all listed down here. And actually I just realized, oh my gosh, I didn't have the Blender tab open. I'm new to OBS. I don't know half the stuff that I'm doing in it. So I'm going to go through that again, just so you guys can see, because I messed up. Alright, so add, mesh, math function, XYZ math surface, and it already filled in all our stuff, but it would give you, you would get this snail shape, and it automatically fills in some math equations for you. So if you go to Atventa, right, you see here you have the x equation in the top box, y equation, z, and then the u min, u max, u step, as well as u rep, and then the v min, max, and step. So we're just going to be copying all of those different numbers as we're using them. So we're going to start. If we go and we copy the x equation and we paste that into Blender, then you should see it gets really skewed. And actually, I don't know how to do like dual window, or where I go to the tab, it automatically switches. So I'm just going to tell you guys what I'm doing, and you guys have seen the Atventa slide. So just you can go back in the video and reference that if necessary. So if we go and we copy the y equation, then you'll see we have this Fibonacci sequence, or it looks somewhat like a Fibonacci sequence. Kind of goes all the way around, and just set the z equation to 0, since we're making a two-dimensional plane right now. Then u min is going to remain at 0. U max is going to be 0.7358 according to Atventa. So if we just mark that, you'll see it changes to this really small curve. U step, which is going to be 1. Or wait, wrong one, it's going to be 10. V step is 1. Okay, U step is 10, and check or uncheck U wrap. And now we have this curve. We're going to go ahead and set our V min and max to 0, and our V step to 1. Tab into edit mode, go and find the vertex select mode, and we're just going to hit F3 and merge by distance. And that's just going to merge all duplicate vertices so we don't have a bunch of excess geometry. Now what we want to do is we want to mirror this along the x, or across the x-axis. So the way we're going to do that is make sure that our transform pivot point is set to the 3D cursor, which is the world origin right here. Shift D to duplicate, and then S to scale, Y on the y-axis, and -1. And now you can see it's scaled across the x-axis. Now I want to take this line that we've just made, and we want to rotate it around the world origin to start creating the first tooth. And the way that we're going to do that is that we take the tooth thickness at base degree from Atventa. That's going to be the number of degrees that we need to rotate it in order to get the correct tooth shape. So in this case, that is 16.7079. Control C to copy. And then if we go RZ, make sure it's rotating around the world origin, and Control V to paste. That's going to put that number right in there. And you can start to see we kind of get this tooth shape, but not nearly complete. So the next step is select the two end vertices here and hit F to join them. Select all of this and then duplicate it using Shift D, and then R, Z, make sure it's rotating around the world origin. And we want to do the number of teeth that we're going to be making, so in this case 12. We want to do 360 degrees divided by 12 teeth, which gives us 30 degrees. That's where we're going to want to rotate it. We're going to want to rotate it 30 degrees. and you'll see we now have 2 teeth here. In order to create the fillet in here and complete the actual tooth shape, we're going to select the endpoints of both of these teeth, Shift S, cursor to selected. Now you can deselect one of the points, doesn't really matter which one. F3 to open up the menu, type in spin, and then mesh.spin, spin function. Now depending on which tooth you selected, you're either going to want to set this to 180 or negative 180. I have the top one selected, so I'm going to go with negative 180, and you can see immediately we have this sort of circle formed. Now I like to set the steps to 16, so that we just have a little bit more geometry there, give us a slightly smoother edge once we start making it 3-dimensional. But yeah, that's the basic shape. Now A, F3, merge by distance, and that's going to remove this vertex right here where it spun around and was directly on top of that. Now if we just take this, Shift D, and then R, Z, so we're I forgot to reset the world origin to the center. So Shift S, cursor to world origin, and you can see the world origin cursor is now at the center. So again, make sure we're orbiting around the center. Shift D, R, Z, and 30. And then I like to hit enter and then Shift R to just repeat the last function. And all of a sudden, you start to see we have a gear shape coming together. Now I'm actually going to Control Z to undo those real quick because I forgot to do a step. This cavity right here is not completely incorrect, but it's not as good as it can be. So just go ahead and select the middle point, enable proportional editing with O, and then just drag it toward the center a little bit. Something like that should work fine. And that'll allow a little bit more room for the opposing gear's teeth to intersect with the surface. So again, A to select everything, Shift D, R, Z, and 30. Spin it all the way around, and there you go. That is the 2D edge of a gear. If we hit A, F3, merge by distance, that'll get rid of all of the excess vertices, in this case 276. And that's the start right there. So the next step is to take this outline and make it 3-dimensional. So we're going to start, make sure we're still in edit mode, and hit E, Z to extrude along the Z axis, and 1. In this case, I'm going to do, well, no, we'll just keep it at 1. 1 works just fine. Now you can see we've turned our curve into an actual 3-dimensional wall, but now we need to actually put a face on the top and add the center where the axle or whatever rod you are going to put the gear on would go. So we're going to start by selecting any of the teeth, doesn't really matter, and just select as many points as you want, but make sure they're proportional on both sides. So I'm going to go to these 2 points right here and just select 4 points out. So that should be good. You can do 5, you can do 3, doesn't really matter, but keep it somewhere in that range. If we hit F, that's going to create a face right there, and that is going to be the first step to the top surface. If we go to face select, select that again, Shift D, R, Z, and 30. Shift R to repeat the function, and there's the top of all of our teeth. If we now do Shift G and select similar by area, it's going to select all of those faces. We'll go ahead and Shift D to duplicate, Z and -1. Now those are attached to the bottom. Now if we select everything, F3, merge by distance, it's now all connected. And we want to go back to vertex selection, push down Alt, and select one of these edges. You can see it selects the entire inside ring. Now what we're going to want to do with this is we're going to want to go and we're going to look at the vertice count. In this case it's 108. That's going to be important when we create the center ring. So Shift S, cursor to selected, add a circle, and set the vertice to 108, or whatever the outside ring was. And you can see we now have a lot of excess points, but it's the exact amount for these outside edges. So if we select this and Shift Alt to select that ring, F3, bridge, edge loops, and would you look at that, we now have a solid surface. And the topology, extremely clean, pretty much about as good as it could get. But we still have this other side which is hollow. So to fix that, we're going to select the center ring, like so, and then extrude it down, so EZ -1, and then do the same thing, but this is now our circle. Shift Alt the edge, F3, and bridge edge loops. Now what on earth is happening there? Oh, that's why we had a point down there. Alright, try that again. There we go. Now that should be 100% closed. Just checking. Yep. Alright. So if we go ahead and go to the overlays and face orientation, you're going to see the normals are completely messed up. These are on the outside, these are on the inside, and it doesn't quite know what it's looking at. So we're going to select everything with A, F3, or in this case, I guess we could do Alt-N as well, recalculate outside for the normals. And that's going to just make all of this clean, which is going to help when we go to texturing and any future operations with beveling or anything like that. So now this is our gear, right? It's complete. I'm going to tab out of this. You can see we still have the wireframe. Just go over to Object Properties, Viewport Display, and unselect wireframe. We can go to the overlays and undo the face orientation, and that's our gear. Now what I like to do, I like to go to the modifiers and toss a bevel on there. Not that strong. Just a little tiny something, which makes it look a lot more realistic when we're lighting it, because real life rarely ever has crisp edges. If we go in, back into edit mode, and we select this edge right here, Shift G, select similar by length. It's going to select all of those edges, and we're just going to bevel it until right before our bevel disappears. It's right there, and add a few more faces. And that'll give us those rounded edges. Now you can see all these face lines right here. We don't want that, so just select it, right click, shade auto smooth, and there you go. That is a complete gear. Now in texturing, we have no texture on it right now. I'm just gonna go, I'm using the Blender Kit library, which has a bunch of free textures and models, all sorts of stuff. It's great, it's a free add-on. Definitely suggest looking into that. But if we look at our menu right here, I found, I believe, it's this one that I liked. I have to check. You just drag it onto your model, and there you go. It now has the material applied to it. You go to rendered, and I'm gonna select a couple of these things. Put the plane back on, and the lights, why not? Now I have the lights set up not to be highlighting this one, but the original scene. But if I just scoot this over like so, you can see it has a pretty nice material to it. It might have actually been this one. I'm trying to find. There was one that I really liked. Yes. Okay, this one. But you can see, like, just with a single click, instant materials. Yeah, great add-on. Definitely recommend it. But now you ask, what if we want to make the gears move? And not just have one rotating, that's as simple as just keyframing the rotation. But what if we wanted to have one where if we rotate this, the other one will rotate along with it? Well, let's start by creating a second gear. I'm just gonna kind of speed through this one. But if we go back, and we're gonna do, say, 30 teeth this time. Same process as before. Just copying all the different numbers from Advanta. That's strange. Probably because I had the excess vertices still and I forgot to merge by distance. Why? Oh, proportional editing, that's why. Forgot to turn that off. I was so confused there for a second. It's like, why is it moving all of those together? Right. Same thing here. Connect. A duplicate by 20 this time. Or actually, not 20, sorry, 12. Not 100, but 12. Select that. Center. Deselect. Spin. Merge the vertices. Select that. Proportional editing. Drag it in. Select everything. Merge by distance. Perfect. I go over, just like last time. Select teeth. Find the big group. 1, 2, 3. I'm gonna do 4. Face. Select, Shift D, R, Z, 12. Perfect. select all by area. And actually, I guess we forgot to scale it. Yeah, so I'm gonna go ahead. Actually, we can keep those there. If we just do this, take that back. Okay, that's not gonna work. When I work quickly, I usually forget steps, and it's annoying, but Z1, do just like that. Now we can go ahead and do this part. Select all by area. D, C, F1, A, merge by distance. Same thing, create, actually we need to select this ring to set the center. Create a circle. Hold on a second. Let's just select, okay, there we go. I don't know why that didn't work the first time. This, 240. Shift Alt. Select the outside rim. And bridge edge loops. What the? Okay, something is going wrong again. But what? Oh, it's this thing right here. Kind of? No. What is going wrong? I'm gonna focus on just this one. Back into material view. I did this like a million times before this. Okay, that's why. Okay. We're gonna have to undo a bunch of steps. I accidentally selected 5 on one of the vertice counts when I was creating this face. So you guys can see the problem right here. So here's our big group, and then 1, 2, 3, 4, 5, but on this side I only selected 4. I'm gonna go to that. That just goes to show you how simple of a problem can affect the entire result later on. Which is the most frustrating thing ever, and I do that on almost every single Blender tutorial I follow, is I'll make everything and it won't be the same. But that's because I missed some very, very minute detail halfway through that just messed everything up later on. Alright, but that was a pretty simple fix. And it should work now. Shift select all of that. And bridge edge loops. No, it's still being weird. Why would that be? 270. If I add a circle. What if I just make the circle bigger? We'll see if that makes a difference. No. What am I missing here? I had a problem similar to this before, and it was really annoying. The only thing I did to fix it was to just start on the other side. So let's see if that fixes our problem. And why that is, I don't know. Probably never know. See, if we just do the other side first, it fixes it. Why? No idea. But we can actually scale this back down to its original size. E, Z, negative, or 1, negative 1. Now use this as our circle, Shift Alt. That, bridge. And there we go, now it's working perfectly fine. Blender has so many small details that I don't know what causes the problem half the time, which makes it really annoying when you're trying to find something out, figure out what's going wrong, and it's not working properly. But what are you gonna do? I don't know how to recode it and fix it myself. So we just leave it as is. Go ahead and toss our bevel on here, which is, oh, this is why you have to recalculate the normals. Otherwise, modifiers and all that have issues working. And it should be working. Oh wait, that's why. All of these vertices are too close together to bevel. Come on. It's not. There we go. If we do like that. Now does it work? No, it does not. Why? It's all falling apart. Why are you not beveling? And all of these look a little strange as well. What are you? That is very strange. And I almost bet that's the problem. So that's that. But why do we have so much extra geometry right here? I'm gonna do something that's probably a little bit harsh. Okay, so I have no idea how we ended up with a bunch of extra geometry there. I'm sure when I go back and watch it, it'll make a whole lot more sense, and I'll see what I messed up on. But for right now, we're just going to duplicate a bunch of the geometry. Select all by length. Bevel. Perfect. Now we have 2 gears. We can see that because all of the calculations came from Adventa, we can now see that these gears will perfectly mesh up. Just like so. So I'm going to go ahead and put that one back in the center. Drag this guy over a little bit more. If we apply the rotation on this, and we select this one, the bigger one, right click Z, add driver. And we're going to pull down the drivers menu, which I already had opened, but if you need to open a new tab, just wait till it makes a little crosshair and drag, and then it'll open a new page. So we want to make sure this is selected, go Z rotation, and where it's red here, it says object, we want to select this, and that's going to be our reference object. Now I don't know why it adjusts like that. And it's very strange. I've had that happen on a whole bunch of them, and I can't figure out what the problem is there. But if we set this to negative variable times the number of teeth on the smaller gear divided by the number of teeth on the bigger gear, you'll see that when I rotate this one, or should work, oh, not Z location, Z rotation. Okay, there we go. You'll see when I go into here, hit RZ, they now rotate with each other. And basically what that driver is doing is it's saying variable is the rotation of this smaller gear, and so when we do negative, right, it's saying take whatever degree this rotates and rotate this the exact opposite. And that's why you get them both rotating into each other. And then we divided the teeth numbers because this gear is larger, right? So obviously if I were to rotate this one 10 degrees and this one 10 degrees, they wouldn't rotate the same amount, if you know what I'm saying, because the bigger one has a larger circumference and therefore will cover more distance. So that dividing of the teeth numbers gives us the change in angle that we would need to rotate to travel the same amount of distance. And so that's how you get them working together perfectly. So now, real quick, I kind of want to go into gear reductions, possibly. Not quite sure. I haven't tried this a lot. I've done it once successfully, so this might get a little bit messy. But if I go, and I'm going to change the hole size here back to 1 just so they're all the same. Come on, select. It should let us keep our bevel, right? Yep, perfect. I'm just going to duplicate the small gear so that I don't have to make a second one. Move it up on the Z by 1. And I'm just going to do like 1.2 just so there's a little gap. Change the Y to 0, and now you can see that the big gear and the small gear are centered on this hole. And basically what that allows us to do is if we put another big gear on the original small gear, that one will actually travel slower than, I don't know exactly how to explain this. It's difficult, but let's see here. Yeah, I'm not sure how to explain that, but I will just demonstrate it to you guys. So if I duplicate the big gear, Shift D, Z, 1.2, and we copy this, move that over, you can see these two are now linked and these are meshing together. We're going to want to apply the rotation of both of these. This one still has a driver on it, which is interesting. But we're basically going to want to add a driver to the small one here, link it to this large gear, Z rotation, and variable is just going to remain the exact same. So that you see when we turn this one, those are, ignore this large gear because it's not set up yet, but you can see that the small gear here and the big gear here are rotating the exact same. So they're basically connected. Now this large gear, we want to change the variable so it's not based on the small one on the bottom here, but instead on this one. And that should, what is happening here? We have to line it up again. Until those are meshed. If we apply rotation, now it should work. Yeah, there we go. So now you can see when I rotate this one, right now they're all working together. And from the top, rotating this one, you can see those are working the same. But you can tell that the two big gears are actually rotating at different speeds. And that's what a gear reduction does. Basically going into the same principle I went on before, where this has a bigger circumference and therefore rotates slower. If we pair the small gear to the large gear here, it's going to be rotating at the same speed as the big gear, which is rotating slower than this one. So again, if we just duplicate this a whole bunch, I'm actually going to go ahead and do that. Let's see. Hold on. Where did I set these to? Oh, well, okay, 1.2, so it's B DZ 2.4. All right. Select that, delete single driver. I'm just going to apply the rotation of both. Add a driver here. Add a driver here. Make this driver equivalent to that gear. Not sure why I did that, but then we'll make this gear equivalent to this one and do the same negative variable times 12 divided by 30. Set this to Z rotation as well. You can see now we have that one set up. And I'm just going to do another one, why not? A lot of gears. And you'll see it goes just progressively slower and slower and slower. Add driver. Add driver. This driver is the same as this gear. And this driver, same as that. With negative variable times 12 divided by 30. And now you can see if I start with the original gear and rotate it a whole bunch, you can see it just gets progressively slower and slower and slower to the point where these ones on the top are barely moving, but you can see the ones on the bottom are going absolutely crazy. So now let's just say change this back to 0. If I animate this, select I to keyframe, 500, why not? Oh, not 50, 500. If I go all the way over here to 500, just gonna set this at like 5,000 degrees of rotation. So it's going to spin around a whole bunch. Make sure both of those are selected. Interpolation, linear, so it's a constant speed. See if we spin around, those are going fast, and these are going slower. And this is the same principle that you'll see in a lot of engines and a lot of different machines to control speed. And sometimes they'll have, I might be wrong here, but I believe it's the same function as a clutch as well in a manual car or on some machines, where it can switch the drive gear to say this one, right? And if I'm rotating this one, these are going to rotate faster, just because of, you know, if this small gear here is going the speed as this one, then it just kind of moves the same function, and this one becomes the speed of that one. But yeah, there you go. That is a simple gear reduction, and you can see it did not copy over the materials. So we'll just go ahead and stop. This one, yeah. Copy all that over to this brushed aluminum. Actually, you just select all of these and copy material. Where is it? Control L. Oh, link materials. There we go. So now they all have that cool plane back on. Where did our lights go? They seem to have disappeared. Oh, I'll go ahead and add a new one then. Light. Set that to 1000. We start to get some of that really nice lighting. And we'll create our area light. Scale that up a bunch. Move it over here. Perfect. Go ahead and move our camera over. Facing the other way maybe. Oh, that's why our camera has, we need to increase this too. A lot more. Put these in line. And there we go. All ready to, I'm going to do like that, point that down a little bit more. I love the rings that you get with this material. Really quite cool. There we go. Yeah, that's cool material. And then if we go ahead and launch our animation, you can see they are in fact rotating and all at different speeds. So yeah, hopefully that helped somebody out and you guys can recreate this. I don't have a link to the file in the description, but if you just leave a comment asking for it, if I see it, I will get back to you and I can probably send it to you. We'll figure out a way. Or, you know, it's a tutorial. You follow it, and it's fairly simple. Not a whole lot of advanced stuff. So you should be able to follow it pretty easy. All right. Well, I'm going to go ahead and end this and probably continue working on this. Maybe make a fun animation to post later. Got a couple more interesting ones coming up, but I've been really busy. And in about a month, I leave for 2 years. And then when I come back, I'll probably continue this, but then I'll be in college. So it'll get even busier. But yeah, thank you everybody so much for watching. And I will see you guys later. Bye.